So in this video, I am attempting to make this design. A context has an API for commands. It will have these functions, and the context will create an event, and it will send it to the specific gen server, which is responsible for broadcasting. Right now, we don't even have that done here. Because if we do it in each channel, it doesn't have a central place to go. We do need to forward them so that we can execute certain game logic there? Or is it that we can have it functionally living inside each channel? Like, why do we need this thing? We need this thing in order to create sequential numbers. So it has to receive at a single place. Otherwise, every space channel would create its own sequential numbers. Okay, the gen server then forwards them to a queued broadcaster. And then that thing will that's a kind of producer, and then the GenStage has a consumer that subscribes to the producer and writes to a database. So I have this file here called event broadcaster. Let me rename this to queued broadcaster, the code of which I've modified from the GenStage documentation. So there's queue broadcaster. Queue broadcaster. So first you initialize this, and then we won't send it synchronous notifications, so we'll take this away. We'll send it asynchronous notifications. So you can send an event in here, and it will call GenStage cast asynchronous notify. In the init here, we're initializing ourselves as a type of producer. We have a new queue. Here's our state, which is a queue and a demand. And then we're specifying a dispatcher, which is some kind of atom. I'm not sure what this does. Accumulates demand from all consumers before broadcasting events to all of them. So it's some kind of queuer. If a producer uses this, its subscribers can specify an optional selector function that receives the event and returns a boolean in the subscription options. Consumer, okay, subscribe to. Okay, so you can specify which messages you want. Not applicable to us because we're receiving everything. So we're going to remove the handle call. I've modified this to be handle cast, async notify, and here's the state, which was the queue and some pending demand. Now here we push into the queue, get back a new queue, we push the event in, and we call dispatch events recursive function with the new version of the queue, which has an event in it, forward the pending demand and any events. So when we handle cast, we're dispatching events with no events the first time. We've just put it into the queue. And here's a handle demand, which comes from the consumer. It says incoming demand, and then the state. And this also dispatches events. Passing the queue, accumulating the demand, so it takes the incoming demand, adds it to the previous state pending demand, and then no events. So both of these kick these off for the first time. Now these call each other, and it's a bit tricky. So this is the sort of stopping condition, that when dispatch events is calling itself with 0, no demand, then it will simply take any events that were passed to it in the last recursive step, reverse the events, and then reset the state to be probably an empty queue and no demand. Or whatever the state the queue is. It might not be empty, but you've recursed down to the demand that you had, and so you're forwarding whatever left you have in the queue. In dispatch events, here I did some inspection just to check the state of this. We'll recurse and inspect the contents of the queue. So here, if you have something in the queue, you'll get back a value and the last or the next item in the queue. So if it's FIFO, it'll be the first item that you put in, and a new version of the queue having that element removed. And so in this scenario, the queue is not empty. We'll dispatch event. So all we really did was we took the event out of the queue. Now we're calling ourselves again with the modified queue minus that element, but pushed the event onto any list that was given to you. So it's like we're pulling these things out and putting them out here until the demand gets to 0, which puts us in this end state, and then we flush it. So this keeps happening between dispatch events, recurse. We exhausted our demand, flush this thing out. And on the other hand, if the queue is empty, then we won't recurse. We'll just set the state to be queue and the current demand, and I think this is the response. But since it's no reply, I'm not sure that this goes anywhere. Or it's possible it might send this as the events that it goes to the consumer, but it won't recurse down. It'll just end there. And then here's just sort of my catch-all to see if we ever ended up in this state where nothing matched. And, oh, no, I need to fix that. What is this complaining about, though? Oh, it can never match. Okay, so looks like we totally matched all the values. You either get empty or value. That's good to know. And what is okay? So now that we have this in place, we need to start this up. So we can do that inside our application. If we specify that as one of the children, so we can say the XRQ broadcaster. That should start it up, and if that's up, then we can also start up the XR event writer. And let's take a look at event writer. It start GenStage again with this module, and it's a consumer. The state does not matter. We subscribe to Q broadcaster with max demand of 100 events and a minimum demand of 50, so we'll ask for more events when we get there. And how we handle the events right now is just we'll sleep for a second, and then we inspect the events, and we say writer.events, and then this doesn't matter. So this will automatically subscribe us to that, and we should see some output messages. Now if we go to our space server, previously when we send it messages via the process event, we go GenServer cast, and we cast to ourselves event. So we go handle cast, event, we go, here's the state. Okay, so we've been pushing it into the state as such. Okay, so I don't think we need that. We don't need this portion here. We do want the next sequence number though. Let me remove the event here. Okay, so we create a new event, which is this thing. And okay, so actually what we want is not to call this method. What we want is just this portion, I think, or even just this, the event, but we need the sequence. So maybe we want this. This is almost like the handle command part. So we have this sequence numbers. I'm gonna go with this. The payload is this. This is essentially what will be saved into the event. Space ID, it's got a type, it has a sequence number, and it's got a payload. So we'll send this to the XRQ broadcaster async notify with this thing. So this has to be validated. Well, right now it's just yeah, it might break if the thing you give it is not instruct, like if you, or maybe this can be extracted to a function. But anyway, that will send a message to the queue broadcaster, and then it should get written to the database at some point. So, what does our test say? Event tester. Events test. Here we have been creating a space supervisor. Oh, I mean, we've been starting a space, and then we have events, this event and this event, and then we said process event, which sends it through here, and then we slept for 50 milliseconds, and then we went to check to see if it's there. So this should, in theory, still work. Let's see what we get. So next test. Okay, could not start the application. Failed to start child. Start length 1 is undefined for private. Okay, let's take a look. Application. So this name is start link. So I need start link with something. So it starts the link with empty arguments. So I guess we can take empty arguments. And in the writer, we can do that as well. Okay, so we got a failure, but nothing came out. But we do have some output here. Okay, so in our output, we get a queue, demand for 100, queue is empty, and in the queue, next iteration, queue has that map in it. Demand is still 100, and then it went through another iteration, queue is not empty, demand shrinks down, and that means something was delivered, right? So we should see that the writer got something. 98, 99. So in our writer, here we were saying writer got events. Did we actually get something? Let's search. Writer got events. Down. This was some previous output. Oh, we're still sleeping for a whole second here. Let's take this out. Hopefully you can see that. Okay, right, I got events. One event there. And we got events. For now, let's just write them. So if we say space server was calling this thing, create event for every event, num map events, and do event, just call this for now. And we can do a to-do, which is write all events in bulk. And we have written it. So let's remove some of our output here. Okay, so we successfully did this part. Gen server. We just send the event and it doesn't queue it, it just sends it along. Sends this along to the queue broadcaster. Meanwhile, when we handle cast, you might want to listen for particular things and react anyway. Okay, I think this is a good milestone. We can stop here.